So now let's start the set theory gate questions. Tell me the answer for this question. This is a gate 1995 question. The number of elements in the power set of S. The number of elements. The question is asking what is the number of elements in the power set PS of set S. So this we already know that if you have a set S such that its cardinality is n, then what will be cardinality of power set? That will be 2 power n. So if the set S has n elements, then the power set will have 2 power n elements because the number of subsets will be 2 power n. So in this S, what is the cardinality of S? How many elements this set S has? So you can notice this is an element, this is an element, this is an element. Total 3 elements you have. This set S has 3 elements. Remember, in this set S, this is an element. This is an element. This is an element of S. Okay, so what is this element? This element is basically, this is the element. So you can note this element itself is a set. Similarly, this element itself is a set. So there is no problem. In set S, you have 3 elements. So finally, I can say that from here, I can say what is the cardinality, what is the number of elements in the power set? That will be number of subset of S. Number of subset of S will be 2 power 3. That will be 8. So the answer will be 8. Now let's move on. Tell me the answer for this question. This is a UGC NET question. UGC NET Computer Science 2012 question. Tell me the power set of set this. So you can notice your set that is given to you, that is set containing empty set. Please understand that this is not same as this. This is empty set. Okay, this set is empty set. But this set is not empty set. In this set you have, this is not empty. Okay, this set is not empty because there is one element. In this set there is one element. This is the element. Okay, so these two are not same. So if I ask you the cardinality of empty set, that will be 0. But if I ask you the cardinality of this set, the cardinality of this set, that will be 1. Okay, so what is the power set of this? So for this, you can notice that power set will contain all the subsets. So for this set, you only have one element. So the power set will contain all the subset. This is a subset. Empty set is subset of every set. Empty set is a subset of every set for all sets S. So you can see phi comma S itself. So the answer will be option B. Option B is the answer. You can easily check that this is a set S whose cardinality is 1. Okay, so definitely the power set cardinality will be 2. Okay, so from here you can easily see that the cardinality of power set, that will be 2. So automatically the answer will be option B. Now let's move on. Tell me the answer for this question. This is GATE 1996 question. Can you try? Don't watch this video like a movie. You can solve the questions with me. Take your copy pen and solve it. This is a GATE 1996 question. In this question, 2 sets are given to you. Set A, set B, 2 sets are given to you. Set A, set B. And their complements are given to you. A complement, B complement. That denote the complement of A comma B. These are the complements. Then the question is asking what is A minus B, union B minus A, union A intersection B. So this question, as I told you, most of the questions in set theory, you can solve using Venn diagram. So you can create a Venn diagram. This is your set A. This is your set B. This is the set B. Then what is this set? The question is asking what is A minus B, union B minus A, union A intersection B. This is what the question is asking. So let me tell you one by one. First of all, let's see what is A minus B. First of all, let me tell you what is A minus B. The white. A minus B is this area, the white area. This is the A minus B area. Okay, let me tell you what is B minus A. Which area is B minus A? So this area is B minus A. You can notice. And finally, which area is A intersection B? This area is A intersection B. So if you take their union, if you do union of this and this, if you take the union, as you can notice, union, so this is nothing but A union B. So your answer will be A union B. You can usually solve using the Venn diagram. The answer will be A union B. Okay. So with the Venn diagram, you can easily solve this question. Okay. Now let's move on. Let's see this. This is GATE 2006 question. Can you try? This is, the question is saying that P comma Q comma R, these are set. Okay. So you have three set P, Q, R. And this is denoting the symmetric difference. This is denoting the symmetric difference. Symmetric difference means P union Q minus P intersection Q. This we already know. We already know that if you have this symmetric difference, if you notice this symmetric difference, then that is same as from the union you remove the common part. From the union you remove the intersection, because if this is your P, this is your Q, then you can easily see this area and this area, that is your P symmetric difference Q, and that is from the union you are removing the common part, you are removing the intersection. You can also say that P minus Q union Q minus P, that also you can say. Okay. And remember, this you can say P intersection Q bar union, this you can say Q intersection P bar. So that also you can say. All these are same. Now the question is saying that using Venn diagram, the question is also saying that use the Venn diagram. The question itself is saying, okay. So the question itself, this 2006, this question itself is saying that using the Venn diagram determine which of them is true. So two options are given to you. Let's see the option number 1. So the option number 1, what is that? That is P symmetric difference, and then you have Q intersection R. Okay. And the RHS, look at the RHS. RHS is P symmetric difference Q intersection P symmetric difference R. Okay. Actually, if you notice, this is a distributive property, right? Basically, what you are doing, you are distributing this symmetric difference over intersection. So this is distributive property of symmetric difference you are distributing over intersection. So you can see P symmetric difference Q intersection R, that is equal to P symmetric difference Q intersection P symmetric difference R. This is symmetry. This is basically the distributive property, but we don't know whether this distributive property is correct or not. We don't know. We have to check whether this distribution we can do or not. We don't know. So let's check. So first of all, what you can do, you can create this Venn diagram. So let me create this Venn diagram. This is your P, this is your Q, and this is your R. These are the Venn diagram. So, and this is your universal set. This is the universal set. Now, how many areas are there in this Venn diagram? Tell me. Let me tell you how to solve this question with the best way, with the best method. Tell me how many areas are there in this Venn diagram. When you see this Venn diagram, look at this Venn diagram. How many areas do you see? When you have 3 set, right? In this Venn diagram, you have created total 3 set. So you have 3 set P, Q, R. In this Venn diagram, there are total 8 areas, right? Yes or no? So there are total 2 power 3 areas in the Venn diagram. In the Venn diagram, there are total 2 power 3 means 8 areas. Total 8 areas. Like this is your area number 1. This is your area number 2. This is your area number 3. This is your area number 4, 5, 6, 7. And this is your area number 8. So total 8 area you have. Is this clear? Total 8 area you have. Area number 1, 2, 3. Sorry, area number 1, 2, 3. Then you have area number 4, 5, 6, 7, 8. Total 8 area you have. Okay. Now you tell me, what are the areas that are covered by this? What are the areas that are covered by this? One by one I am asking. Okay. First you forget about this one. Now you tell me about this one. What are the areas that this is covering? First of all, you can notice that this Q intersection R, what area it will cover? Q intersection R. Q intersection R. This is Q intersection R. That is your 4,7 area, right? Okay. Q intersection R, that is 4,7 area, because this is Q, this is R. Look at this. Look at Q, R. Only look at Q, R. What is Q intersection R? That is 4,7. This area, 4,7. Okay, now this symmetric difference with P, symmetric difference with P. So 4 comma 7 symmetric difference, this area symmetric difference with P. So that is the exclusive area. Remember, this means exclusive. This means exclusive. What is P? What areas P has? P has 1, 5, 6, 7. So what are the exclusive areas? So finally, what are the exclusive areas? Tell me. This area, exclusive this area. What are the exclusive areas in these two? P has 1, 5, 6, 7. This is what P has. P 1, 5, 6, 7. And this Q intersection R, this has 4, 7. What is exclusive between these two? Between these two, 4, 7, these two. What is exclusive? You can notice 1, 5, 6. This is exclusive in P. And this 4 is exclusive in Q intersection R. This is the exclusive, right? Yes or no? Do you understand the meaning of exclusive? Exclusive means exclusive, like exclusive news. Like exclusive news. What it means? Let's assume there are two TV channels. Let's assume there are two TV channels. For example, let's assume one is like G News. Okay, whatever. Like you have one is G News, another is Aaj Tak. So there are two TV channels. Exclusive news means this exclusive news. It means that either G News has and Aaj Tak does not have, or Aaj Tak has and G News does not have. This is called exclusive news, right? Yes or no? So you can easily see that. Look at this P. P is 1, 5, 6, 7. This is P. Look at Q intersection R. That is 4, 7. What is exclusive between these two? 4, 7. This is the news at the Aaj Tak. Aaj Tak has this news, and let's assume G News has this news. So what are the exclusive news? You can notice 1, 5, 6. This is the exclusive news to the G News, and this is the exclusive news. Sorry, this is the exclusive news to the Aaj Tak. So something like that. You can finally see this is the exclusive news. 1, 5, 6, 7. 1, 5, 6, 4. Now let's see. So this area is 1, 5, 6, 4. This is the area. Okay, let's check this one. Let's check this one. Tell me about this one. What is the area it will have? Exclusive in P, Q. What is exclusive in P, Q? Exclusive in P, Q. Remember, exclusive. Exclusive in P, Q. P has what? P has 1, 5, 6, 7. Q has 2, 4, 5, 7. Okay, P has 1, 5, 6, 7. Q has 2, 4, 5, 7. What is exclusive? Tell me, what is exclusive? Exclusive is, I can say exclusive will be 1, 6. 1, 6 is exclusive. 2, 4 is exclusive. Okay, what? Similarly, this R has what? R has this area 3, 5, 6, 7. So what is exclusive? What is exclusive? Tell me. P has 1, 5, 6, 7. So what is exclusive? Exclusive will be, that will be 1, 5, 3, 4. What is intersection finally? What is intersection of these two? This and this. What is the intersection of these two? What is the common part in these two? The common part is 1, 4, right? The common part is 1, 4. So finally, this is 1, 4. Now can you tell me the answer? Now can you tell me the answer? Now very easily you can see they are not equal, right? This is subset of this one, the upper one. So you can easily see this is P exclusive or Q, intersection P exclusive or R. So this is subset of this. So they are not equal. They are not equivalent. These two are not equal. These two are not equal. So remember, this is false. So this is a false. This distributive property is false. Did you understand this? Tell me, did you like this method? See, this area method, did you like? Let me know. Did you like this method? This area method? Very easily you can solve using this method very easily. Without any confusion, very easily you can solve this question. All these questions with this method. Okay, so I hope this is understood. So okay, so what is this option A? Actually, we have seen this option 1. Let me tell you, this is false. But what this was option A was? This option A was saying that P symmetric difference Q intersection R, that is same as P symmetric difference Q intersection P symmetric difference R. So this is false. So this is false. What it means? So this is false. What it means? It means that I can say that symmetric difference is not distributive over intersection. So I can say this symmetric difference is not distributive. It is not distributive over intersection. Okay, symmetric difference that is not distributive over intersection. So this is what it means. So this is your option number 1. Now let's see the option number 2. The option number 2, that is something different. So let's check. So P intersection Q intersection R, that is very simple, right? Yes or no? This is simply P intersection Q intersection R. This is the common part. We have to check this. What is this? P intersection Q, symmetric difference, P symmetric difference R. So let's check it out. So the second option. In the second option, you have P intersection Q intersection R. That is same as P intersection Q, symmetric difference, P symmetric difference R. Okay, P intersection Q, symmetric difference, P symmetric difference R. So this is the question. This is your question number 2. Can you try this? This is the second part of this question. So very easily you can do. This is nothing actually. So what you can do, you can just create a Venn diagram. This Venn diagram you can create. This is your P. This is the Q. And this is the R. Okay. And this is your M. This is your universal set M. So there are how many areas you have? You have these many area. 1, 2, 3, 4, 5, 6, 7, 8 total area. So what is the area of P intersection Q intersection R? What is this area? This area is area number 7, right? Yes or no? Area number 7. So for this, the area number 7 is the okay. What about this one? Can you tell me what is the area of this one? What is the area of this one? P intersection Q. P intersection Q. The area is 5, 7. That is the intersection Q. Okay, so 5, 7. This is the area. I can say 57. I can say 5, 7. This is the area. What is the area here? Like remember, this P has what area? This P has 1, 5, 6, 7. 1, 5, 6, 7. This R has 3, 4, 6, 7. So what is the exclusive? What is the exclusive between these two? What is the exclusive between these two? This and this. What is the exclusive? The exclusive in 1, 5. Okay. 1, 5, 3, 4. This is the exclusive. Now you tell me the exclusive here. Now you tell me the exclusive here and here. What is the exclusive here and here? That exclusive will be 1, 3, 4, 7, right? Yes or no? That exclusive is 1, 3, 4, 7. So this is your exclusive. And here you only have 7. So definitely they are also not equal. And I can say this. So finally I can say that this is correct. I can say this is subset of this. This is correct. Because ultimately this area, if you look at, this will give you the area of 1, 3, 4, 7. So definitely this statement is false. So I can say that if you have this statement that this is equal to this is a false. This statement is false. Okay, so finally the answer will be that this is also false. The question is asking which is true. So the answer will be neither first comma second. The answer will be option C. Did you understand? Please tell me. This area method is very nice area, very nice method. If you have 3 set PQR, then you can create 2 power 3 areas you can create in the Venn diagram, and then you can solve any questions using these areas. You can easily solve whatever question you want to solve. You can easily solve. Now let's move on. Let's see this question. This is a GATE 2008 question. Can you try this? Don't see the question like a movie. Solve the question with me. I am also solving, you also solve. So let's see this. So very simple question again. You have 3 PQ are subset of universal set U. So U is a universal set. The question has given to you, the universal set is given, that is U. And these are the subset of universal set. Now the question that is asking, then what is this set? Okay, so again you can solve this question very easily by the Venn diagram method. So what the question is saying, that there are three sets. There is universal set M, or U is the universal set. So for a moment, this U, let me call it M for a moment, so that we are not confused. This U, let's call it M. So this U, let's call it M. Okay, so I am calling it M so that we don't get confused between these two symbols. Like, see, these two symbols, they look very same. Union and universal set, these two symbols. So let me call it M. So I am calling it M. There are three sets. There is set P, there is set Q, there is set R. So there are three sets. So you have three sets. Now, what the question is asking? The question is asking this area, union this area, union this area, union this area. Okay, so let's see one by one. So very simple if you solve this question like this. First of all, P intersection Q intersection R. What is this area? Then the question is asking union. Okay, then the question is asking, what the question is asking? It is asking union P complement intersection P complement intersection Q intersection R. Okay, then question is asking union Q complement, union Q complement. Then the question is asking union R complement. Okay, so this is what the question is asking. So first of all, what is this area? Tell me. Like if I ask you, what is this area? This area will be, you can notice that this is area 1, 2, 3, 4, 5, 6, 7, 8. So what will be the final, this area will be area number 7. Now the same question again I am asking. So, okay, so you can notice 1, 2, 3, 4, 5, 6, 7, 8. So tell me, this area we found, that is 7 area. What is this area? What is this one? Look at this one. What this is saying? This is saying Q and R but not P. Yes or no? Look at this. If I say like this, what this means? This means Q and R but not P. This means Q and R but not in P. Right? Okay, so you can see this is the area where Q area and R area in Q and R. It must be in Q, it must be in R, but it not in P. Okay, so you tell me what is this area? Like you must be in Q comma R, Q and R. You must be in Q and R, but you must not be in P. So that is the area number 4. Yes or no? The area number 4. Correct. So now finally, so this union will give me 7 comma 4. This union will give me 7 comma 4. So I got this union. This union I got, that is 7 comma 4. This union is giving me 7 comma 4. Okay. So 4 comma 7 area I got. Now you tell me what further? 4, 5, 6, 7, 8. Now what is this Q complement area? Q complement, that is everything that is not in Q. Everything that is not in Q, like 1, 3, 6, everything that is not in Q. So that is 1, 3, 6, 8. This is your Q complement. Okay, Q complement will be 1, 3, 6, 8. So finally this union will give me what? This union will give me 1, 3, 4, 6, 7, 8. Okay, so I got 1, 3, 4, 6, 7, 8. Okay, remember so far what I got 1, 3, 4, 6, 7, 8. If you see this will give me 1, 3, 4, 6, 7, 8. And what this will give me? R complement. What R complement will give me? So this R complement will give me anything which is not in R. So it will give me 1, 2, 5, 8. Finally, this union will give me what? ultimately this union, this is giving me what area? Ultimately, what this area, this union is giving me, this is giving me 1, 2, 3, 4, 5, 6, 7, 8. So I got everything. That is universal set, right? Yes or no? So ultimately I got universal set. So the answer will be option D. So this is very simple method. Please tell me, did you like this method? Let me know. Very simple. What you can do, just make the Venn diagram and you can find the area. Nothing in this question, there is nothing. All you have to do, just make the Venn diagram and find the area. Like let me create on side. Just solve the question using Venn diagram very easily. This is your Venn diagram in which you have this set, and this is your P, this is your Q, this is your R. Then what you do, you divide this in area. Like as I told you, 1, 2, 3, you can divide into 4, 5, 6, 7, 8. Okay, so now you can easily see this P and Q and R. This is area number 7. This P complement Q and R. This is means Q and R, but not in P. Q and R. Okay, means 4, 7, but not in P. So that will be 4. What is Q complement? Q complement, which anything which is not in Q, So that is this area. And what is R complement? Anything which is not in R. So that is 1 to 5, 8. Now you can do their union. This union, this union, this union. So the answer will be this. Yes or no? Very simple method. Very simple way to solve this question. Is this understood to everyone? Please tell me. Let me know. So this is how you can solve this question very simply. You can also solve the question, the same question you can also solve using the simplification method also. See, what you can do let's see the method number 2. Let's see another method for the same question. You have PQR, that is intersection, union, P complement QR, union, Q complement, union, R complement. Let's solve this question by the another method. See, here you can use a property that we have already seen. Do you remember this property that I told you that, right? Because this is same as B minus A. Because this is same as B minus A. So you can easily say that if this is A, if this is B, then what is, this is your A union B minus A. A union B minus A. That is A union B, right? So this you can apply. This property you can apply. The same property will hold if you do this. A complement union A intersection B, that also will be A complement union B. Okay, so this is what you can do. This you can apply here. So from here you will get Q complement. Okay, so basically this Q you can remove and you will get Q complement union P intersection R. P complement intersection R. So this is what you can do. Now what you can do, as you have this union R complement and you have union PQR. Now from these two, look at from these two. From these two you can say that it will be just R complement union P complement. Okay, so it will be Q complement union PQR. Now what you can do, using these two you can remove this Q. This Q you can remove. See, this rule is actually very simple. You think like this: P union P bar Q. What you can do, basically you can remove this P bar. Okay, basically you can remove this P bar. Similarly, P bar union PQ. Basically you can remove this P. So it will be like this. Same rule you have in the Boolean algebra also. In the Boolean algebra or in the propositional logic, same rule you have. You have the same rule. Like you have this rule, like A or A bar B. Just you can remove this simple, this you can remove. So it will be like A or B. For example, A bar or AB, you can just simply remove this A and it will become A bar or B. So very simple. This rule actually you can apply many times. So here also what you can do, you can simply remove this Q. So it will be PR or, so what you will get PR, union Q bar, union R bar, union P bar. Now you can take this and this and simply you can remove this R. So finally you will get P union Q bar or R bar union P bar. Now look at this. P union P bar. This will be like universal set, union whatever. It does not matter what you have. This is the universal set. So your final answer will be universal set. So this is how you can solve this question with the simplification method. But I think that this method, Venn diagram method, is actually more powerful. So you can use the Venn diagram method. That is actually better way to solve this question. You can very easily solve this question with that method. So remember, note this. This is very important. It will help you very much. That A union A complement B. What you can do? You can remove this A complement. Okay, you can remove this one. So finally, you will get A union B. Similarly, A complement union AB. Okay, that simply will be A complement union B. So like this. Okay, these rules will definitely help you a lot. Okay, this is my question. I wanted to ask you, like, PQR union P bar QR. Can you say something about it? Can you say something about it? Like, for example, this is your PQR. Look at this. This is P, this is Q, this is R, and this is the Venn diagram. For example, this is area number 1, 2, 3, 4, 5, 6, 7, 8. So tell me, what is this one? So you can notice what is PQR. PQR, that is your area number 7. That is PQR. And what is P bar QR? What is P bar QR? P bar QR means Q and R not in P. Q and R not in P. That is 4, 7. So their union basically will be 4, 7 area. Only this 4, 7 area. That means QR. Okay, that means QR. That means Q intersection R. So what I want to say, that this PQR union P bar QR, what you can do, you can write it QR. Actually, you can think like this, that you are taking QR common. You can think like this, that you are taking this QR, you are taking common. It's like similar rule you have in the Boolean algebra. In the Boolean algebra, similar rule you have, for example, ABC or ABC bar. What you can do, you can take AB outside, then it will be like C or C bar. So finally it will be AB. The same thing is happening here also. Are you getting my point? The similar thing is happening here also. If you have PQR union PQR bar, then what you can do, you can take this PQ out. Okay, you can take this PQ out. Then it will be R union R bar. It will be R union R bar. That will be universal set. This will be the universal set. Correct. So this is going to be the universal set M. Now, this is the intersection, of course. Okay, there is a, like, this gap. This gap is the intersection. So intersection with, it's like PQ. Intersection with universal set, that will be PQ. Okay, so this also you can do. I hope this point is clear. So some note, as you can see, these rules, these same rules are also in the Boolean algebra. Okay, all these same rules, as I told you, these same rules, like PQR. If you have PQR union with PQR bar, then that is same as basically PQ. You can take this PQ out. You can take this outside. So it will be like PQ. Similarly, you can notice P union PQ, that will be P. Similarly, P union P bar Q, that will be P union Q. Okay, so these simple rules will definitely help you whenever you are solving the questions. Now, as I told you that in this question, what you can do, in this question, this is nothing but, if you notice, this PQR union, this is nothing but Q intersection R. Okay, union Q complement union R complement. Now you can solve this question even more easily. More easily you can solve. So you can use this way, that Q complement union QR, that will be Q complement or R. So what will happen here? From these two, you will get Q complement union R complement, and that will be your universal set. So that is your universal set if you consider this as M. So the answer will be option D. So you can solve this question in many different ways. Did you get all of them? Please tell me. Did you understand all of them? All the ways did you understand? Okay. So I hope this is clear. So let's solve this TIFR question. Can you tell me the answer quickly? Very quickly. TIFR 2010 question. So the question is saying that you have two set. A complement is given to you. B complement. A complement is denoted like this. A minus B means all the elements which are in A but not in B. So what is A minus B? The question is asking what is A minus B. So very easily you can see if this is your A, if this is your B, then what is A minus B? This is the universal set. Then you can easily see from the A you are removing A minus B. See, this is your A minus B. Correct. Look at this. This is the A minus B area. From A you remove it. From A you remove it. So from A, this is your A. From A you remove it. So this area will be A minus B area, and that is same as A intersection B. So the answer will be A intersection B. Very simple. So the final answer for this question answer will be option D. This is the answer. Okay, so very simply you can do this, or if you want you can do like this also. For example, A minus A intersection B. If you have two set, you have only two set. There is A set, there is set B, and this is your universal set. How many areas will be there in the Venn diagram? In the Venn diagram there will be four area 1 to area 2, area 4. Now you can notice area 1 means 1 3, and this A minus B, and this A minus B. This area, what is this area? This area A minus B. From A you remove the area of B, that is 1. So now 1 3 minus 1 1 3 minus 1, that is your 3, and that is A intersection B. So the answer will be option D. Option D will be the answer for this TIFR question. This is a question from the Illinois University. This is a standard question from the Illinois University. You can try this also. Tell me, this is a multi-choice question. Can you tell me the answer? You have arbitrary set A comma B, random set A comma B. What is A minus B? Multi-choice question. Basically, this is a MSQ question. So can you tell me the answer? What A minus B is equal to? See, option A is basically, look at option A. Option A is like this. The complement of B intersection A complement, right? Yes or no? Because we already know this. We already know this, that if you do A minus B, that is same as A intersection B complement. If you do B minus A, that is same as B intersection A complement. Okay, so if I do A minus B complement, if I do A minus B complement, so that simply means that I am doing A intersection B complement, whole complement, and that will be very simple. That will be A complement union B. Similarly, if I do B minus A complement, that will be what? That is going to be B complement union A. So you can easily see that this will be B complement union A. B complement union A. That is not same as A minus B, because what is A minus B? A minus B is A intersection B complement. Okay, so that is not same. So definitely this A is not answer. What about B? What about B? B is basically A intersection B complement. So yes, B is the answer. What about C? C is not answer. What about D? Yes, D is the answer. What about E? E is not answer. So the answer will be what? That will be B comma D. Yes or no? For this question, the answer will be option B, option D. So these are the answers. You can check it out. So the answer is going to be B comma D. This is another question from this is another standard question from the Illinois University, as I told you. Another standard question from the same university. Can you tell me the answer? This is the last question for this session. Please tell me the answer. With the set 1, 2, 3, this is a set given to you. Set A is given to you. 1, 2, 3. Power set is PA. Power set is PA. Which is true, which is false? So tell me, is this a, see, if something belongs to PA, then what you can say? Simple question I am asking. Tell me, let's assume you have a set A. Tell me, if something belongs to PA, then what can you say about this something? This S belongs to PA. What belongs to PA? What belongs to power set of A? Subset of A, right? So it simply means that S is subset of A. Similarly, if S is subset of A, then definitely S belongs to power set of A. Okay, because in the power set, you have subset of A. Power set is a set containing subset of A. In the power set, every element is subset of A. So if you have some element in power set, that is a subset of A. So tell me, if this belongs to power set of A, is this subset of A? Yes, of course, this is subset of A. So definitely this is correct, because you can see this is subset of A, right? This is subset of A. So this belongs to power set of A. So this is correct. This is subset of power set of A. This is not correct, because 2 is not element. It simply, what this simply means, this is a subset of PA. It simply means that 2 belongs to power set of A. But this is not true. Okay, it simply means that 3 belongs to power set of A. This is not true. So both are basically false. Okay, these two are basically false. You can easily see. So these are basically false. So finally I can say option B is not correct. Okay, what about this one? Phi belongs to PA, of course. Phi is subset of PA, yes, of course. See, very simple thing that whatever set you take, it will always happen. Okay, see, some things you can notice that. You can notice for every set, S, what will happen? This phi will be subset of S. But for every power set, what will happen? For every power set P, okay, for every power set P, this P is a power set. Maybe for some set, power set for some set. So this P is a power set. Then what will happen? Then this phi is belongs to also, because it is a power set of some set, and this phi will be subset of that, and this phi will be subset of P also. Because you can notice, see, if P is a power set, if this P is a power set, then it is a power set of some set, right? Correct? If this P, if this is power set, then for some set, I can say for some set, P is equal to PA. Correct? For some set, this P is a power set of this set A. Now you can easily see that phi is a subset of A. So it automatically means phi will belong to P. This P itself is a set, because this itself is a set. So phi will be a subset of P. So here in this question, the answer will be ACD. The answer is going to be ACD for this question. Okay, I hope you understood all the points